Good day everyone. Today we will be discussing about circular functions. In this video, I'm expecting that you will be able to first illustrate the different circular functions and second, use reference angles to find exact values of circular functions. Special right triangles. I know you are all familiar with this topic because when you were in grade 9, you discussed this topic. But let's have first a review. There are two types of special right triangles. The first one is the 30, 60, 90. And the second one is the 45, 45, 90 degrees. In finding six trigonometric functions pertaining for special right triangles, we are using SOHCAHTOA and CHOSHCAHTOA. But what do we mean by SOHCAHTOA? SOHCAHTOA means sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent is equal to opposite over adjacent. While once we said CHOSHCAHTOA, it means cosecant is equal to hypotenuse over opposite. Secant is equal to hypotenuse over adjacent. And cotangent is equal to adjacent over opposite. What do we mean by opposite? Once we said opposite, katapat. Once we said adjacent, katabi. And once we said hypotenuse, that's the longest side. Let's try a given example. Let's find six trigonometric functions of 30 degrees. Therefore, we're going to use the first illustration, which is the illustration A, because 30 degrees is here. Now, let's apply SOHCAHTOA and CHOSHCAHTOA. Let's start with finding sine. Sine 30 degrees is equal to opposite over hypotenuse. Now, let's take a look on 30 degrees. Katapat ng 30 degrees is 1. Therefore, instead of writing O, we're going to write 1. And instead of writing H, we're going to write 2 because the measurement of the given hypotenuse is 2. That's the reason why sine 30 degrees is equal to 1/2. Let's now find cosine. Cosine 30 degrees is equal to adjacent over hypotenuse. The side adjacent to 30 degrees is equal to square root of 3. That's the reason why instead of writing A, we're going to write square root of 3. And then instead of writing hypotenuse, like what I told you, the value of the hypotenuse or the measurement of the hypotenuse is equal to 2. That's the reason why cosine 30 degrees is equal to square root of 3 over 2. For tangent 30 degrees, we're going to use opposite over adjacent. Again, the side opposite to 30 degrees has a measurement of 1, and the side adjacent to 30 degrees has measurement square root of 3. Therefore, we're going to have 1 over square root of 3. But why it becomes square root of 3 over 3? Because we rationalize the denominator. So, 1 over square root of 3 times, we're going to multiply that by square root of 3, both numerator and denominator, so that we're going to rationalize the given fraction. From that, we're going to have 1 times square root of 3 is square root of 3, and square root of 3 times square root of 3 is equal to 3. That's the reason why tan 30 degrees is equal to square root of 3 over 3. Now, for cosecant 30 degrees, that's equal to hypotenuse over opposite. As you can see, it's just only the reciprocal of sine 30 degrees. Why? Because cosecant is just a reciprocal of sine. Then second is for cosine, and cotangent is for tangent. So now, instead of writing H, we're going to write 2, and instead of writing opposite, we're going to write 1. Simplifying 2 over 1 will become 2. For secant 30 degrees, again, the value or the measurement of hypotenuse is equal to 2, and the measurement of the angle of the side adjacent to 30 degrees is square root of 3. So we're going to rationalize the same thing, the same process on what we did on tangent 30. We multiply both numerator and denominator by 30 by square root of 3. Thus, we're going to have 2 square root of 3 over 3. For cotangent 30 degrees, we're going to use adjacent over opposite. So instead of writing A, we're going to write square root of 3. And instead of writing O, we're going to write 1. Thus, square root of 3 over 1 is equal to square root of 3. Let's try another example. So again, we have this special right triangles and the technique or the pattern, SOHCAHTOA and CHOSHCAHTOA. Let's find six trigonometric functions of 45 degrees. So we have illustration A and illustration B. So based on the two illustrations, since we're looking for 45 degrees, we're going to use illustration B because 45 degrees is here. Now let's find sine 45 degrees. Again, we're going to use opposite over hypotenuse. As you can see, the measurement of the side opposite to 45 degrees is this one, and that is equal to square root of 2. And the measurement of the hypotenuse is equal to 1. Therefore, instead of writing O, we're going to write square root of 2, and instead of writing H, we're going to write 1. Thus, square root of 2 over 1 is equal to square root of 2. Let's find cosine 45 degrees. Cosine 45 degrees is equal to adjacent over hypotenuse. Now, the measurement of the side adjacent to 45 degrees is square root of 2. So instead of writing A, we're going to write square root of 2. And instead of writing H, we're going to write 1. Thus, square root of 2 over 1 is equal to square root of 2. Now, let's find the tangent. Tangent 45 is equal to opposite over adjacent. Opposite is equal to square root of 2, like what we discussed. And adjacent is equal to square root of 2. Thus, square root of 2 over square root of 2 is equal to 1. Therefore, tangent 45 is equal to 1. Now, let's find cosecant. Cosecant 45 is equal to H over O, or hypotenuse over opposite. And that's equal to 1 over square root of 2. Now, by rationalizing 1 over square root of 2, like what we discussed, in rationalizing, we multiply both numerator and denominator by square root of 2. So 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is just only 2. That's the reason why cosecant 45 degrees is equal to square root of 2 over 2. For secant 45, we have H over A. Again, H is equal to 1. And the side adjacent to 45 degrees is equal to square root of 2. Now, by rationalizing again the denominator, we have square root of 2 over 2. Now, for cotangent 45 degrees, we have A over O, or adjacent over opposite. Again, the side adjacent and opposite to 45 degrees are equal to square root of 2 and square root of 2. Therefore, square root of 2 divided by square root of 2 is equal to 1. Therefore, cotangent 45 degrees is equal to 1. Let us now have this one, the summary of the 6 trigonometric functions of 30 degrees, 45 degrees, and 60 degrees. This is very important. We need to familiarize ourselves with the 6 trigonometric functions because later on, we're going to use this so that we're going to find 6 trigonometric functions of angle measures greater than 360 degrees or greater than 90 degrees. So, let's now have quadrantal angles. So, how are we going to know 6 trigonometric functions pertaining for quadrantal angles? If we're talking about quadrantal angles, we're dealing with angle measures 0, 90, 180, 270, and 360 degrees. Thus, it implies that these are angles falls in axis. So, we have here 0, 90, 180, 270, and 360 degrees. Now, this table is very helpful in order for us to find 6 trigonometric functions. So, as you can see, if it falls in 0 degree, therefore, x is equal to 1 and y equals to 0. And if it falls in 90 degrees, x is equal to 0 and y is equal to 1. In order for us or for you to easily familiarize yourself with this one, if the angle falls in x-axis, therefore, x is equal to 1 and y is equal to 0. But if the angle falls in y-axis, y is equal to 1 and x is equal to 0. However, if it falls in 180, x will be equal to negative 1, while if it falls in 270 degrees, y is equal to negative 1. No need to memorize yourself with r because r is always equal to 1. Why? Because we're dealing with a unit circle. Let's find 6 trigonometric functions of 180 degrees. To find sine 180 degrees, we have y over r. So instead of writing y, we're going to substitute the value because we're dealing with 180 degrees. We're going to use this data. y is equal to 0. So instead of writing y, we're going to write 0. Instead of writing r, we're going to write 1. So 0 over 1 is equal to 0. So therefore, sine 180 is equal to 0. For cosine 180 degrees, instead of writing x, we're going to write negative 1. Instead of writing r, we're going to write 1. And simplifying negative 1 divided by 1, that's equal to negative 1. So cosine 180 is equal to negative 1. For tangent 180, that's equal to y over x. So instead of writing y, we're going to write 0. And instead of writing x, we're going to write negative 1. 0 divided by negative 1 is equal to 0. Therefore, tangent 180 degrees is equal to 0. Now let's find cosecant 180. For cosecant 180, we're just simply using r over y. So instead of writing r, we're going to write 1. Instead of writing y, we're going to write 0. 1 over 0 is equal to undefined. Just always remember, any number that you divide by 0, the answer is equal to undefined. Okay? Let's have secant 180. For secant 180, we're going to have r over x. We just only get the reciprocal of the pattern for sine, cosine, tangent for cosecant and for secant and for cotangent. For secant 180, we have r over x. We just simply get the reciprocal of x over r. And 1 over negative 1 is equal to negative 1. For cotangent 180, that's x over y. We just simply get the reciprocal of y over x. So x is equal to negative 1 and y equals to 0. Again, like what I told you, any number that you divide by 0 is equal to undefined. So therefore, cotangent 180 is equal to undefined. Let's try another example. Again, we're going to use this pattern and let's find 6 trigonometric functions of 90 degrees. So since 90 degrees, we're going to use this data. X equals 0, y equals 1, and r equals 1. And we're going to use the same pattern. For sine, we have y over r. So instead of writing y, we're going to write 1. And instead of writing r, we're going to write 1. So 1 divided by 1 is equal to 1. Therefore, sine 90 is equal to 1. For cosine 90, we're going to use x over r again. So instead of writing x, we're going to use 0 or substitute 0. Instead of writing r, we're going to write 1. 0 divided by 1 is 0, thus cos 90 is equal to 0. For tangent 90, that's y over x. Instead of writing y, we're going to write 1. And instead of writing x, we're going to write 0. Again, like what I told you, any number that you divide by 0 is equal to undefined. Next, for cosecant 90, we have r over y. We just simply get the reciprocal of y over r. So r is equal to 1 and y equals 1. So 1 divided by 1 is equal to 1. Therefore, cosecant 90 is equal to 1. For secant 90, that's r over x. R is equal to 1 and x equals to 0. Since there is 0 in the denominator, therefore, the answer is undefined. For cotangent 90, that's x over y. So that's 0 over 1. Since 0 is in the numerator, therefore, that's equal to 0. So this learning will be very vital in order for us to find 6 trigonometric functions of other angle measure. Let's now use reference angle in finding 6 trigonometric functions. So in finding the reference angle, we need to take note of this information. For quadrant 1, we have theta. And then all trigonometric functions are positive. So if it is theta, therefore, if it is in quadrant 1, therefore the theta is greater than 0 but less than 90 degrees. Or theta is less than 0 but greater than pi over 2 if it is in radian measure. For quadrant 2, we use 180 degrees minus theta in finding the reference angle. And in quadrant 2, if the angle measure falls in quadrant 2, only sine and cosecant are positive, while other trigonometric functions are negative. How are we going to know if the angle measure falls in quadrant 2? If the given theta is less than 90 degrees but greater than 180 degrees. Or if it is in radian measure, the given theta is less than pi over 2 but greater than pi. If the given angle measure falls in quadrant 3, then in order for us to find the reference angle, we use theta minus 180 degrees. And in quadrant 3, only tangent and cotangent are positive, while other trigonometric functions are negative. How are we going to know if the given angle measure falls in quadrant 3? If the given theta is less than pi, but greater than 3 pi over 2. Or, if the given theta is less than 180, but greater than 270 degrees. Now, for quadrant 4, we use 360 degree minus theta in order for us to find the reference angle. Now, in quadrant 4, only cosine and secant are positive, while other trigonometric functions are negative. How are we going to know if the given angle measure falls in quadrant 4? If the given theta is less than 270, but greater than 360. Or if it is in radian measure, the given theta is greater than 3 pi over 2, but less than 2 pi. Again, take note of the following. In finding the reference angle, if it is in quadrant 1, just only copy the angle measure. But if it is in quadrant 2, we use 180 degrees minus theta. If it is in quadrant 3, we use theta minus 180 degrees. And if it is in quadrant 4, we use 360 degrees minus theta. Take note of that because we're going to use the reference angle in finding 6 trigonometric functions of the given angle measure. Again, and also, in order for us to have the rule of sign, just always remember that if it is in quadrant 1, all trigonometric functions are positive. But if it falls in quadrant 2, only sine and cosecant are positive. While if it is in quadrant 3, only tangent and cotangent are positive. If it is in quadrant 4, only cosine and secant are positive. Let's try an example. Okay, let's find 6 trigonometric functions of 1710 degrees. The first step is to find the least positive angle coterminal with a given angle measure. We already discussed this on our last meeting. So now, to find the least positive angle coterminal with 1710 degrees, we're going to use or to apply the formula theta minus 360k. To find the value of k, we're going to have 1710 divided by 360. And that is equal to 4.75. Therefore, k is equal to 4. Let us now substitute the value of k, which is equal to 4, and the angle measure 1710 degrees. So instead of writing theta, we're going to write 1710 minus 360. Instead of writing k, we're going to write 4. So 1710 minus 360 times 4 is equal to 270 degrees. So the least positive angle coterminal with the given angle measure is 270 degrees. The second step is find the reference angle of the least positive angle coterminal with the given angle measure. Since the least positive angle coterminal with 1710 degrees is 270 degrees, therefore there is no reference angle because it falls in y-axis. The next is use the 6 trigonometric functions of the reference angle and apply the rule of sign. So therefore, we're going to use this table because we have a quadrantal angle. So we're dealing with 270 degrees. So therefore, we're going to apply this data, or we're going to substitute this data. So let's now have the 6 trigonometric functions. For sine 1710 degrees, again, we're going to apply y over r. So for y, instead of writing y, we're going to write negative 1. Instead of writing r, we're going to write 1. Negative 1 divided by 1 is equal to negative 1. For cosine 1710 degrees, instead of writing x, we're going to write 0. Instead of writing r, we're going to write 1. 0 divided by 1 is equal to 0. For tangent 1710 degrees, we have y over x. Instead of writing y, we're going to write negative 1. And instead of writing x, we're going to write 0. Since there is 0 in the denominator, therefore the answer is undefined. In order for us to find cosecant 1710 degrees, it's equal to r over y. So instead of writing r, we're going to write 1, and instead of writing y, we're going to write negative 1. 1 divided by negative 1 is equal to negative 1. Therefore, cosecant 1710 is equal to negative 1. For secant 1710, we have r over x. R is equal to 1 and x equals to 0. Since there is denominator in the since there is 0 in the denominator, therefore the secant 1710 is equal to undefined. For cotangent 1710, that's equal to x over y. Instead of writing x, that's equal to 0, and instead of writing y, we're going to write negative 1. 0 divided by negative 1 is equal to 0. Therefore, cotangent 1710 is equal to 0. So, when are we going to apply this table? We're going to apply this table if the given least positive angle coterminal to the given angle measure is a quadrantal angle. Okay? Let's try another example. Find 6 trigonometric functions of negative 2655. First step is to find the least positive angle coterminal with a given angle measure. So since this is negative, we're going to apply 360 times k plus 1 minus theta. In order for us to find k, we're going to divide 2655 divided by 360. 2655 divided by 360 is equal to 7.375. Therefore, k is equal to 7. Let us now substitute the value of k, which is 7, and the given theta, which is negative 2655 degrees. So let's substitute. Let's bring down 360. Then, parentheses, instead of writing k, we're going to write 7 plus 1 minus 2655 degrees. Now, the next step is to simplify 360 times 8 minus 2655, which is equal to 225 degrees. Therefore, the least positive angle coterminal with negative 2655 degrees is 225 degrees. Now, to find the reference angle of the least positive angle coterminal with a given angle measure, we have 225 degrees, and 225 degrees is in between 180 to 270. Therefore, it falls in quadrant 3. So, since it falls in quadrant 3, we're going to apply theta minus 180. So, let's bring down 225 minus 180, or let's substitute. Instead of writing theta, we're going to write 225 minus 180, we have 45 degrees. So, therefore, the reference angle of negative 2655 degrees is 45 degrees. After that, we're going to use 6 trigonometric functions of the reference angle and apply the rule of sine. So, we're going to apply or use this table. I already show you this table for 30, 45, and 60 degrees. Since our reference angle is 45 degrees, we will just simply apply or write these values for 6 trigonometric functions and apply the rule of sine. Since negative 2655 degrees fall in quadrant 3, therefore, we can say that only tangent and cotangent are positive, while other 6 trigonometric functions are negative. Let us now find sine negative 2655, which is equal to square root of 2 over 2. We just simply copy square root of 2 over 2, square root of 2 over 2 for cosine, 1 for tangent, square root of 2 for cosecant, square root of 2 for secant, and 1 for cotangent. Now, then, after writing the 6 trigonometric functions pertaining for the reference angle, what are we going to do? Apply the rule of sine. Since it falls in quadrant 3, only tangent and cotangent are positive. So, therefore, this will be positive, tangent and cotangent. And the 4 trigonometric functions, which are sine, cosine, cosecant, and secant, will be negative. And therefore, that will be 6 trigonometric functions of negative 2655 degrees. Let's try another example. Find the 6 trigonometric functions of 37 pi over 6 rad. So, in order for us to find the 6 trigonometric function of this region measure, let's start converting this region measure with the degree measure. So, we have 37 pi over 6 times 180 over pi. So cancel pi. 6 and 180 can be cancelled and it can be 30. 37 times 30 is equal to 1,110 degrees. So therefore, we're dealing with 1,110 degrees. So let's now proceed with the steps. So we're going to find the least positive angle coterminal with 1,110 degrees. So to find the least positive angle coterminal with 1,110 degrees, we're going to apply theta minus 360k. To find k, we're going to divide 1110 divided by 360. 1110 divided by 360 is equal to 3.08. So therefore, k is equal to 3. Let us now substitute the value of k, which is equal to 3, and the given angle measure, which is 1,110. So instead of writing theta, we're going to write 1,110 minus 360. Instead of writing k, we're going to write 3. 1,110 minus 360 times 3 is equal to 30 degrees. So therefore, the least positive angle coterminal with 37 pi over 6 rad is pi over 6 or 30 degrees. Now, to find the reference angle of the least positive angle coterminal with a given angle measure, we're going to write 30 degrees. And let's check on what quadrant does 30 degrees fall. Since it is in between 0 to 90 degrees, therefore, it falls in quadrant 1. Since it falls in quadrant 1, it's just to find the reference angle, it's just simply the theta, which is equal to 30 degrees. So therefore, we're going to use 30 degrees. Now, let's use the trigonometric functions of the reference angle and apply the rule of sine. So let's use this table and apply the 6 trigonometric functions for 30 degrees. So we'll just simply copy this one for 6 trigonometric functions, and then we're going to apply the rule of sine. So let's have the 6 trigonometric functions of 37 pi over 6. So we'll just simply copy. For sine, we have 1/2. For cosine, we have square root of 3 over 2. For tangent, we have square root of 3 over 3. For cosecant, we have 2. For secant, we have 2 square root of 3 over 3. And for cotangent, we have square root of 3. After that, we're going to apply the rule of sine. So in order for us to apply the rule of sine, we need to know on what quadrant does 37 pi over 6 lie. Since it is 30 degrees, the coterminal angle or the least positive angle coterminal with 37 pi over 6 is 30 degrees. Therefore, it falls in quadrant 1. In quadrant 1, the condition is all trigonometric functions are positive. Therefore, this is the exact value of the 6 trigonometric functions of 37 pi over 6. Let's try another example. If p theta is a point in a unit circle and theta is equal to 17 pi over 3, what are the coordinates of p theta? If we are asked about this one, we'll just simply use cos theta, sin theta. So for x, it is a representation for cos theta, and a representation for y is just simply the value of sin theta. So therefore, we just simply get, or we need to find cosine of 17 pi over 3 and sine 17 pi over 3. Let's start finding first the coterminal angle. But before finding the coterminal angle, we need to transform this into degree measure so that it will be easy for us to find the coterminal angle. So 17 pi over 3 times 180 over pi. Cancel pi. 180 and 3 can be cancelled and it will be 60. 60 times 17 is equal to 1020 degrees. So therefore, we're just looking for the coterminal angle or least positive angle coterminal with 1020 degrees. So we're dealing with least positive angle. Okay. So now, we're going to use theta minus 360k. To find k, we need to divide 1020 by 360. 1020 divided by 360 is 2.83. So therefore, k is equal to 2. Let's substitute 1020 minus 360 times 2, and that's equal to 300 degrees. Now, let's find the reference angle. So we have 300 degrees. And 300 degrees is in between 270 to 360 degrees. Therefore, it lies in quadrant 4. Since it lies in quadrant 4, therefore, we're going to use the formula 360 minus theta. So we're going to substitute. Instead of writing theta, we're going to write 300. So 360 minus 300 is equal to 60 degrees. Therefore, the reference angle of 17 pi over 3 is just 60 degrees or pi over 3. Now let's find sine 17 pi over 3 and cosine 17 pi over 3. So sine 17 pi over 3 is equal to negative square root of 3 over 2, and cosine 17 pi over 3 is equal to 1/2. Why? Because we use sine 60, which is equal to square root of 3 over 2, and we use cosine 60, which is equal to 1/2. After that, we apply the rule of sine. Since it falls in quadrant 4, only cosine and secant are positive. That's the reason why cosine is positive and sine is negative. Now, after having this one, we're going to substitute the value of cosine 17 pi over 3, and that's 1/2, and sine 17 pi over 3, which is equal to negative square root of 3 over 2. Therefore, the coordinate is 1/2 and negative square root of 3 over 2. Let's try another example. If p theta is a point on a unit circle and p theta is located at 2, 3, then find the 6 trigonometric functions of the given. Since we have location at 2, 3, and that is a representation for x, y, therefore x is equal to 2 and y is equal to 3. Now we're going to find r. To find the value of r, we're going to use r squared is equal to x squared plus y squared. So we have r is equal to the square root of x squared, which is 2 squared, plus y, which is 3 squared. So r is equal to the square root of 4 plus 9, which is 13. So therefore, your r is equal to square root of 13. Now, after having the values for x, y, and r, the next step is substitution process. We're going to have sine theta, which is equal to y over r. So instead of writing y, we're going to write 3. Instead of writing r, we're going to write square root of 13. Since there is radical in the denominator, we need to rationalize. So let's multiply both numerator and denominator by square root of 13. So therefore, we have 3 square root of 13 over 13. For cosine, we have x over r. So therefore, we're going to substitute. Instead of writing x, we're going to write 2. Instead of writing r, we're going to write square root of 13. Since there is radical in the denominator, we need to multiply both numerator and denominator by square root of 13. So we have 2 square root of 13 over 13. Next is tangent theta is equal to y over x. So I know you are all familiar with the pattern because this is just only the pattern that we use in quadrantal angle. Okay? Now we're going to have, instead of writing y, we're going to have 3. Instead of writing x, we're going to have 2. So this is just simply the value of tan theta. Let's now proceed with cosecant theta. So for cosecant theta is equal to r over y. So instead of writing r, we're going to write square root of 13. Instead of writing y, we're going to write 3. So therefore, cosecant theta is equal to square root of 13 over 3. Let's now have secant theta. Secant theta is equal to r over x. Your r is equal to square root of 13 and your x is 2. Therefore, secant theta is equal to square root of 13 over 2. For cotangent theta, we have x over y. So instead of writing x, we're going to write 2. And instead of writing y, we're going to write 3. So therefore, these are the 6 trigonometric functions of the given problem. Let's now have. Given cos A equals 4 over 5 and sine A is greater than 0, find the values of other trigonometric functions. Let's start with cos A. So cos A is equal to 4/5. Our pattern for cosine is x over r. Thus, we can say that x is equal to 4, y, and r is equal to 5. We're looking for y. To find the value of y, we're going to use r squared is equal to x squared plus y squared. So we have r, which is 5 squared, is equal to x, which is 4 squared, plus y squared. 5 squared is equal to 25 equals 16 plus y squared. Let's transpose 16. We have 25 minus 16 equals y squared. 25 minus 16 is equal to 9 equals y squared. Squaring both sides, we have y is equal to 3. Therefore, we have the values x is equal to 4, y equals to 3, and r equals 5. After that is the substitution process. So we have sine A equals y over r. Instead of writing y, we're going to write 3. And instead of writing r, we're going to write 5. Next, for cos A, we have x over r. So instead of writing x, we're going to write 4. And instead of writing r, we're going to write 5. For tangent A, we have y over x. So instead of writing y, we're going to write 3. And instead of writing x, we're going to write 4. For cosecant A, we just simply get the reciprocal of 3 over 5, which is equal to 5/3. Or just simply substitute 2r over y. Next, for secant A, it's just simply equal to 5 over 4. And for cotangent A, it's just simply 4 over 3. After writing or substituting the given values, let us now proceed with the condition. The condition is cos A is equal to positive, sine A is greater than 0. Since sine is greater than 0, it implies that sine is also positive. The sine and cosine are only positive on quadrant 1. Therefore, angle measure or the given theta falls in quadrant 1. Since in quadrant 1, all trigonometric functions are positive, therefore, will be our final answer. The 6 trigonometric functions for angle A. Let's proceed with the next example. Given tan A is equal to negative 12 pip and theta is greater than 3 pi over 2 but less than 2 pi, find the values of other trigonometric functions. Let's start with tangent A. Tangent A is equal to negative 12 over 5. Our pattern for tangent is y over x. So therefore, we can say that x is equal to 5, y equals 12, and we're looking for r. We disregard first the negative sign because we have the rule for sine. So let's now have r squared is equal to x squared plus y squared. So we have r is equal to the square root of x, which is 5 squared, plus y, which is 12 squared. So r is equal to the square root of 25 plus 144. So we have r is equal to the square root of 169 and r is equal to 13. So we have values. X is equal to 5, y equals 12, and r equals 13. Let us now proceed with the substitution process. Sine A equals y over r. So we're going to substitute the values of y and r, and that is 12 over 13. We have cos A equals x over r. By substitution process, we have 5 over 13. For tangent A, we have y over x. By substitution process, we have 12 over 5. For cosecant A, we have r over y. So therefore, by substitution process, we're going to have 13 over 12. For secant A, it will be equal to 13 over 5. And for cotangent A, it will be 5 over 12. After writing or substituting all the given values, the next step is knowing where the theta falls. Tangent A is negative. And as we can see, the condition is this one. The theta is in between 3 pi over 2 and 2 pi. Since it is in between 3 pi over 2 and 2 pi, like what we discussed, theta falls in quadrant 4. So in quadrant 4, the rule is only cosine and secant are positive. So therefore, this will only be positive, cos A and sec A. Otherwise, sine A, cosecant A, tangent A, and cotangent A are negative. So we're going to put negative. And that will be our final answer. So these are the 6 trigonometric functions based on our condition. So that's all. Thank you and happy math learning. I hope you've learned a lot for today's discussion.